Okay, sig figs, right? So I'm going to start. What is a sig fig? The name itself tells you what is a sig fig. Sig fig means most important significant numbers. Okay, so what is a significant numbers? So Jade told me she's going to give me a check. She told, I'm going to send you a check. And she told me a number. And I still remember. She gave me this, she told she's going to send me a check. How many dollars is that? $7 million. So when she wrote a check, she actually forgot this number. And she just put zeros and gave me.
That's a lot better.
So what happened to that 7? So which is the most important number in that? 7. So how many, that means the most important number is the significant number. So how many significant numbers are there? So in this number, which is the most important number?
7.
So how many important numbers are there?
1.
So this type of numbers where there is only one sig fig number. Now you will ask me, does the zeros count or don't count? Zeros will count, but under certain circumstances. So before I go further, I want to teach you there are 3 types of zeros are there. Zeros which are coming after a number, which is right of that number, right side of the number. Those type of zeros are called as?
Trailing.
What's that?
Trailing zero.
Trailing zeros. Trailing, like a trailer. So which are right side. Trailing zeros are never significant if there is no decimal in a number. Is there a decimal in this number? No. When there is no decimal in a number, they are not significant. So all non-zero digits are significant. How many non-zero digits are there in this number?
1.
1. So it's check mark. So total how many sig figs is this?
1 sig.
1 sig fig. The next question is okay. Now, trailing zeros are only significant if there is a decimal in a number. So if I put the same number like this, and then if I put a decimal anywhere in that number, I can put a decimal here. So now what happens? According to the rule number 1, all non-zero digits are significant. So this is always a check mark. Now comes next one. What are these zeros called which are coming on the right side behind a number? Trailing. Trailing zeros are not significant, but they are significant only if there is a decimal. Is there a decimal in this number?
Mm-hmm.
There is a dot, right? That's all. So what do you put check mark? So how many check marks are total? 7 sig fig number. The zeros, this decimal can be anywhere in this number. I can rewrite this number like this one. Is there a decimal in this number? So that means these zeros are trailing are automatically significant. So then this is also total again 7. So decimal can be anywhere. Decimal can be even in the front 0.70 and this is this zeros after a number? What are the zeros called? Trailing. Trailing zeros are significant if there is decimal. Is there a decimal in this number?
Yes.
So there is all checkpoints. That's the one rule. And then this is always checkpoint. So total how many? 7. Okay. Now, the second type of zeros are called, they are coming, which comes in the left of the number, which are coming before a number, like 0.000007. What are these zeros called, which are coming before a number? They are taking, and they are for This 7 is following them, leading. What is that called? Leading zeros. Leading zeros are these are which are on the left side of a non-zero digit. Those are called leading. Leading zeros are never significant. So you just close your eyes and strike off. And now how many non-zero digits are there?
1.
So how many sig fig is this?
1.
1 sig fig. So trade leading zeros never significant. Now third type of zero. What is the third type of zero? So if I put like this,
Captive.
7250067
Captive 0.
So what are these zeros called, which are between 5 and 6 or between the non-zero numbers, digits? They are called as captive zeros. And captive zeros are always significant. Captive zeros are always significant. So you put, so this is always checkpoints. And these are, how many non-zero digits are there in this?
5.
5. 1, 2, 3, 4, 5. Now the last zero, what is this zero called, which is coming on the right side?
Trailing.
Trailing. And trailing is only significant if there is a decimal. Is there a decimal? No, so this is not. So how many sig figs are there? You just underline these. That's all. Okay? So now I'm going to give you a number. You tell me how many sig figs is this. 0.12325007000. Use them. So let's see the rules. See the rules. First rule. What is the first rule says? If you see the first.
Non-zero.
But it's
Yeah.
to the right of the decimal.
Yeah. First. What is the first rule says? Significant. All non-zero digits are
Significant.
significant. So how many non-zero digits are there in this?
3.
3. 1, 2, 3. What is the second rule? Go on the same lane like this. Significant. Trailing zeros in a decimal number. Are there any trailing zeros?
Mm-hmm.
How many?
2.
2.
Which one? This last one, right? Is there a decimal number?
Yeah.
So they are significant. Then what is the third rule says? Significant. Are there any captive zeros?
Yes.
How many?
2.
So they are significant. Right? Now, go to the remaining. What are the non-significant? What is the first non-significant? Leading zeros. Are there any leading zeros? That's it. Are they significant? No. So just strike them off. So now only this count. So how much are those? 1, 2, 3, 4, 5, 6, 7. So 7 significant. Now comes remember which ones are non-significant. Trailing zeros in a non-decimal number are also non-significant. And the last rule says infinite significance. If I have a number in a formula like 4 by 3 pi r cube. So this type of numbers in a formula are called as infinite significance. And I give you one more example. Infinite significance. Counting numbers. Okay, fixed numbers. How many students are there including me today?
5.
6, including me.
Oh.
6. Is there any 6.5 here?
No.
There's no point. It's 6. That's a fixed number, right? So counting numbers are always infinite significant. Like 1 dozen. How many? 12. 1 pair?
2.
2. So if we say 1 pair of this, that's infinite significance. Okay, counting numbers. So those are, so if you follow the sig fig rules, and you can do practice all those numbers below. Now I'm going to teach you rules for sig figs. There are certain rules for sig figs. Okay, there are 2 rules for sig figs. What are the different ways you can calculate, Ms. Jade?
Adding and subtracting and dividing and multiplying.
Adding, subtracting, dividing, multiplication. You all did this before, right? You can add, you can subtract, you divide, you multiply, right? So then now the rule says, first rule says, let's go to this first one. Okay, everybody got the sig figs? It's the same thing. These are all the rules I gave you, that's a chart. I'm going to try to see if everybody can join this one. didn't realize the internet problem. Oh. Yeah, this is coming. If somebody is there.
Somebody still there?
Okay, significant. All these rules I already explained. So significant. So what there is other two rules I'll explain. So what are the two rules I'm going to explain? The other two rules is when you add or subtract, you always, your final answer should be always lowest decimal number. When you add or subtract, your final answer should be lowest decimal number. And here you're going to do something called a rounding. So I'm adding two numbers. 17.653 plus 8.2. So before you do first thing, am I doing adding, right? When add or subtract, your answer should be what?
Lowest decimal.
Lowest decimal. So how many decimal number is this? 3. See, you see 3 digits after a dot, so it's a 3D. How many decimal number is this? 1. So this is 1D. So which is my smaller number?
See?
No, which one? Between 3 and 1, which is a smaller number?
1D.
Which is a smaller decimal? 1, right? So your final answer when you add, after you do the regular addition, you have to round up to the 1 decimal number. So how do you do that? Do the first common addition, the regular. So 3, 5, 8, 5, 2, right? So now, let's see, according to the rule, this is a 3 sig fig, this is 1 sig. 3 decimal, this is 1 decimal. My final answer should be what?
25.9.
1 decimal. 1 decimal means I only need this one, right? So this is 1 decimal. But if your adjacent number is 5 or above 5, what happens to the penultimate number? 1 unit more. So what is my final answer? 25.9. That's the answer. So remember, when you add or subtract, you always go with lowest decimal. Right? Now let's do the next one. When you multiply. So what is the second rule says? When you add, when you divide or subtract. Sorry, when you divide or multiply, your final answer should be what?
Lowest sig fig.
Lowest sig fig. So let's see, I'm going to give you one example. I'll give you one number. Somebody can multiply and tell me. I want to multiply 16.52 times 7.2. Can somebody do that? You can use your calculator. Okay, how much you got?
118.94.
118.9.
44.
44. Okay, now. So let's see. What is the rule you are doing now? Multiplication. So your answer should be what?
Lowest sig fig.
So first, for that you have to identify how many sig fig each is. How many sig fig is this?
4.
4s. How many sig fig is this?
2.
So which is the smaller number?
2.
2. So your final answer should be 2. Right? So how do you convert? So 118.9. So how do you convert into 2 decimal number? So can I round it as 120? Why? How many sig fig is this 120?
2.
If I leave it as, I need 2 sig fig, right? So if I leave it as 2 sig fig like this, 11, that's not the answer. Because is there a difference between 11 and 118.94? The numbers are different, right? But how do you do that? So you round up this number to 2 sig fig. How do you do this? You just put 120 and put to 12. You round up this to 120. And how do you get? So if I round up to 120, how many sig fig is this? 2, because this is a trailing 0 with no decimal. So it's a 2 sig fig. Okay, 2 sig fig. Okay, I'll give you one more example. Can somebody do this? Instead of now, what do you do? Okay. What was this number? Can somebody tell me what was this number?
The 16.
Point.
52.
How much?
52.
16.52 divided by 7.2. Okay. Can somebody do this? I'm doing division now. So which rule I should follow if I'm doing division? Lowest sig fig. So how many sig fig is this? 4. How many sig fig is this? 2. So my final answer should be? So first do the normal division. Can somebody do the normal division?
2.294444.
Hang on.
29.
2.29.
4444.
Okay. So this is the big number, right? How many sig fig is this? This is the number. How many sig fig is that?
6.
6, right? But my answer should be what?
2.
So 2 means I only need what?
2.
So I only need these 2, right?
2.2.
So if this is 2, now what happens? The adjacent number is 9. So what happens to this?
Round.
So it becomes what?
2.3.
So there are 2 rules for sig figs. What are those? When you add or subtract, you go with lowest decimal. When you multiply or divide, you do with lowest sig fig. Okay? Okay, I'm coming. All these are there already. So let's see what is an error in the side. Okay. Okay, let's see what is an uncertainty. Any deviation from the original value is called as uncertainty. So highlight, a degree of doubt in a single measurement is called as uncertainty. Degree of doubt. If you do an experiment, you have a doubt, that's an uncertainty. So determined by measuring the device. So if you want to divide the uncertainty, you should know the instrument, how measuring device. Okay, what is accuracy? So there are 2 definitions, accuracy and precision. So now I'm giving you an example of a dot. You probably place the dots, right? Throwing dots. So if somebody threw a dot, so I'm going to draw here. This is the eye. This is the center bull's eye. Okay. Now, and this is 1. This is 2. This is 3. So now somebody threw a dot here. So every time what is happening is going here, 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 here. It's not going here. Is it? This is the actual value, bullseye. Is it close to the actual value? No. So that, but is it, they are all these throws are all repeatable, they are all together? So that type of repeatability is called as precision. But if somebody threw a dot, exactly, if somebody threw a dot at the actual value, how close your value is close to the actual value, that is called as accuracy. So if you threw here on this, I can say, wow, you are accurate. So what is accuracy? How close your measured value is to the true value, standard value. It's called as that. So this. But if somebody keep throwing this stuff and they're always coming here like this, so you are not accurate, but you are precise because they're repeatable. Okay. So here it is precise, but here it is accurate. So how do you define accuracy? Is an agreement between true value and the measured value. How close they are each other. What is the precision? That is a measurement of the agreement of the multiple measurements that are grouped together, or they are repeatable. Those are called as precision. So remember, what is accuracy, what is precision? Okay. So calculations and simple. So calculations, we did that. This one. Calculation, we just did. So if you see first one, multiply, divide. What is the rule says? The final answer will have the same number of sig figs as the data involved in the multiplication with the least number of sig figs. Okay. The second one, when you add your or Subtract the data involved with the least number of decimals places, determine the sig fix. Okay, so now these are, so you see, now let's see, you can do this easily. How many sig fix is this? 3.67.
3,
3. How many sig fix is this? 2.123.
4,
So when you multiply, your final answer should be how many sig fix?
3.
3, because this is the lowest. So when you do this all, you will get the example in practice. Okay. Okay, next one. What is the next one? Okay. Okay, this is converter to conversion. We'll come back to conversion. Okay, this is our calculations. So exponents. So when you are doing a sig fix, if your number has an exponential form like this, 7.32 times 10 to the power of 5, how many sig fix is this?
3.
3. Because when you have an exponential form like this in a number, they don't count in sig fix. Only they count sig fix. So this is a 3 sig fix number. Okay. This exponential form doesn't count in significance. Only these numbers count. So that's what it says. Exponents, sig fix do not change. So if I want to convert from this, I can multiply this number. You see, I can. This is a. When you see a number with exponential form, it is called as a scientific notation. This is a scientific notation. If I want to write normal notation back, what do? You just multiply this with 10 to the power 5. So if I remove, how many digits are there here? 2. So what is 5 minus 2?
3.
So you just put 7, 3, 2, because they are gone. The decimal is gone, and put 3 zeros. I just did 7.32 times, right? So now, how do you put this multiply? You multiply these two. So when I remove these two decimals, it becomes 5 minus 2, which is 3. So now you just put this number with 3 zeros. So that's what it is. So you can go from a scientific notation to normal notation. It's called a normal notation. Okay, next one. Those you don't need to know those. Okay, like see, I just told you exact numbers are the numbers with the infinite significance. Contains no uncertainty. Rounding numbers, I told you, I just did. If you have a number 5 or above 5 adjacent one, you round up to the nearest whole number. That's what is rounding number. Okay, now comes scientific notation. So what is scientific notation? Scientific notation is when you express, when a compound has exponential form, that is called scientific notation. So let me do one example. Okay, how do you write scientific notation? So 63000. Okay, how many? Is there an exponential form in this? Do you see any exponential form?
No.
So this type of notation is called as normal notation. Normal. Now how do you convert normal notation to scientific notation? So you can do this. This is how you do. You put your left, you put it right. So if there is no decimal, where is the decimal in this number? At last 0. Right? So now you're going to move the decimals. So you have to move, when you're moving from, I'm moving from right towards left, right? So your exponential form will be positive exponential form. When you're moving from right to left. So let's say I'm moving now. So I'm moving from 1, 2, 3, 4, 5, and where I should stop, I just stop here. Because this number, when you come here, this number should be between 1 to 9.999. So if I put 60, if I stop at 63, it's more than 63, more than 10, right? So it has to be, so you stop, when you are coming your decimal from right to left, you stop before the first non-zero digit. Which is the first non-zero digit in this number?
6.
6. Because you're not going to read a number this way, right? You're going to read a number that way. So you stop before that. So how many positions I moved? 1, 2, 3, 4, 5, 6. So how do you write the scientific notation? 6.3, right?
It's 10.
Times, you can omit all the zeros. 6.3 times 10 to the power. How many positions I moved? 6. So if I'm moving from right to left, is it positive exponential or negative?
Positive.
So I put 6. You got it?
And the number has to fall between 1 and 9.9, you say?
Yeah. So, or you just remember, if it's coming from this way to this way, you stop before the first non-zero digit. If you are coming from this way to this way, you stop after the first non-zero digit. Okay? I will do that example also. So now this is the scientific notation. So how many sig fig is this? How many sig fig is this?
The 6.3?
Yeah.
Or
This whole thing.
2?
2. How many sig fig is this when I change to scientific?
2.
So sig figs does not change when you exchange from scientific to normal. Sig fig does not change. So I'll give you one more example of small number. 0.1234563. So where is my, so first thing when you get a number, what is the first thing you do? You put left and right, left, right. Which side the decimal is? On left. So you have to move the decimal from left to right. So where I should move? So now you tell me in this number, which is the first non-zero digit?
6.
6. So you move the decimal after the first non-zero digit. So and if you're moving from left to right, it's negative exponent. Okay. So now you are moving. You see, 1, 2, 3, 4, 5, 6. So can I rewrite this as 6.3 times 10 to the power of, is it negative or positive?
Negative.
Negative 6. Later, you can even simplify this even smaller. So how can you simplify? I will tell you when you read about prefixes, you will learn what is the prefix, what is the name for 10 to the power of 6?
Hexa? No.
Mega.
Yeah.
10 to the power of 6 is megabytes, right? So can I rewrite this as say this is this many meters, 6.3 times 10 to the power of 6 meters. Can I rewrite this as 6.3 megameters? Because this is correspond to mega. Now can somebody do this? What is 10 to the power of negative 6 called as? So 10 to the power of 6 means what? A million. Right? 10 to the power of negative 6 means
Micro.
1 millionth.
Is it micro?
1 over 1 million. Okay, yes. So what is 10 to the power of 6 is called?
Deca? No.
No.
Micro.
Micro.
Okay, so if I have this many meters, so how can we write in the this one using micro? So I can rewrite as 6.3 and this corresponds to micro. So this is the sign for micro. You draw the U first. You draw U first and you pull one arm down. That's micro. So the answer should be micrometers. So if we say 6.3 micrometers, this is the number. 6.3 times 10 to the power of, you don't have to do that. You just put 10 to the power of negative 6. Okay. So I showed you how to convert normal. This is also normal because there is no exponential form. Normal to scientific, scientific to normal. Okay, that's those are scientific notations. So I'm giving you one number. Can you tell me how to convert into normal? 6.45 times 10 to the power of negative 4. Can somebody convert into normal notation? Go back now. This is the 10 to the power of negative 6. It's a small number. So which side I should move the decimal now?
Left to right.
Left.
Left to right.
It's 6.45 times negative. Negative means where this negative came from. This way or this way? That's why. So you go left. You go this way, right? Because it came when you came from there to this side, it was negative, right?
Yeah.
So now I want to go back. So that means this one. So if you see easy way, I'm going to show you.
Okay.
If it's negative 4 means what is 1 unit less than 4 is what?
3.
So you just put you move this decimal here and put just 3 zeros. That's all. If it is negative 4, you put 3 zeros. If it's negative 5, you put 4 zeros. If it is so it's like this. So if I put 10 to the power negative 1, means how much is this? 1/10, right? So we can write as 1/10 as 0.1, right? So it's 0.1. So remember, so how do you write this? To the 10 power 4, you just move that way. So I'm going to give you one more example now. So 7.53 times 10 to the power of 8. How do you write? You are converting scientific to normal now. How many positions I should move?
7 over to
7?
8. The right.
No, but not 7.
Oh.
60.
No. So you just tell me the number. I'll write it.
7, 5, 3, 0, 0, 0, 0, 0, 0.
Okay. So now how many zeros? Yeah. So you see. So how do you do it if you have a number like this? How many digits are there after the decimal?
2,
So what is 8 minus 2?
6.
So you just move the decimal here and put 6 zeros.
Mm.
That's all. Okay. So that's the scientific to normal, normal to scientific. Is it time for us to? No. So much time. It's okay. I just explained. So you see one significant figure to the left decimal. You can move the decimals that way or this way. So here you see now 29 million. So how do you write this? There is 29 million. How do you write? My decimal is at this end. So I am moving 1, 2, 3, 4, 5, 6, and 7. So my answer will, I'm moving from right to left. Is it positive or negative? Right to left.
Positive.
Positive. So that's why I put 2.9 times 10 to the power 7. But here you see now, this one, I'm coming from this way to this way. It's negative. So where I should stop? After this first 3, right? So it will be, see how many power. So you don't have to look there also. How many zeros are there before?
3.
You have 3, so you put 1 unit more. You put 3.3.